Welcome to the Deliberation Working Group. As you've seen, there's no real agenda today because I simply was not able to find someone that would present today. But honestly, I also would like to, in general, have this working group more in an interactive fashion where people also have discussions. And so I guess it would be good if we just um, use this meeting to have a little bit of a round of an update, see what everyone is working on. Would also like to get a bit of a feel again from some of the people that I, to be honest, haven't noticed participating in the meeting so far, um, that are here right now to learn what they are working on, why they're interested in the working group, and maybe we could also see to find some new directions for the working group because we're currently actively working on this Ross enhancement proposal for the behavior trees, as you will know. But of course, there would be also open to see what we can do in future with this working group, what the direction could be. So could I maybe ask you guys to briefly introduce yourself? I see there is Alejandro.
Yes. Hello. Can you
Yes.
hear me? Hey, nice to meet you all. Well, I'm Alejandro. I work at the IRT Gilbert. I don't know. I think
Yeah.
Ludovic is usually present. And well, I mean, for the moment, we're exploring behavior trees to kind of build the behavior for one of our projects. And well, one of the things that we have to do is to remove some screws from a building plate. So there are some screws that have been 3D printed. Um, and the idea is to use a bit the reactivity of behavior trees when we're gonna try to fetch the screw to, well, if we haven't fetched it correctly, to retry the same position several times until we've grabbed it. So that's, well, yeah, that's mainly what we're working on right now. Of course, the behavior is gonna keep expanding, and we will incorporate some things. I have a couple of questions that I wanted to ask you about the blackboard. I don't know if it's the right time to do it or I should wait for it or maybe another time.
Yeah, I would be also interested in. So you have this use case to remove the screws. Do
Yes.
what is the? So I assume you use move it to control the robot.
We're using the CAD
The cut.
for the CAD for the Cartesian trajectories, and then we use Move It for the free movements.
Okay.
Yes.
And then and how's the interface between behavior tree? How do you call then the robot from?
So we created. So there is a driver, Isayaskawa robot that we use. So we have the Motoro's 2 driver. So we can, well, we publish to an action topic, and that's how we command the robot. And then to call the CAD, the planner, we also use there's a service that we call, and that's the way we interface with
Okay.
it.
Yeah. Yeah. I guess feel free to ask your questions. Maybe someone can help, but I think we're not probably not the experts here
Okay.
right now because David is not here.
Okay. All right. All right. Well, maybe you already know it, but it's just so we're potentially going to be using a depth camera afterwards. So it generates 3 point clouds that are very big. So there are about 2 million points, and the size of the file is probably around 12 megabytes. And my question was if the blackboard is supposed to be used um, for for data as big as that.
Mm.
So Blackboard variables can be any object type. So it could
Mhm.
be a point cloud 2 message, or it could be a trajectory message. You can pick it. It's your object.
Mhm.
All the behavior tree library is doing is just passing that object in and out of the behaviors. And so you can make a pointer to it so that you don't like copy it in to your
Mhm.
behaviors and stuff like that.
Right.
That's all allowed, right? You'll have to verify that the data is there and valid or whatever. But yes, absolutely, you can use any object type as an
Okay,
input
perfect.
or output port in the behavior tree library.
Yeah.
Perfect. I was wondering if there was like a limitation to the size of the things that you could handle. Okay.
Yep. Yeah, they can be standard ROS objects, or they can be custom class objects that you've created yourself. As long as the library knows about the object, you can use it.
Okay. Perfect.
Yeah,
Thank
I
you,
would
Mark.
be more actually
problem.
worried for some kind of ROS transport, maybe with these types of data sizes. That this could be more of a
Right,
bottleneck.
but it's sounding like you're going to have a behavior that's going to like get a point cloud, and then you want to pass it to
Yes.
another behavior
Yeah.
that's going to do some calculations. So that's 100% valid. Like I said, the only thing I'd be careful of is just not copying the data.
Okay. Perfect. Yeah, that makes sense.
Yeah, if I can add something, passing, I mean, I don't know the specifics of ROS, so I don't know the internal working, but passing data is, I guess it is a blocking operation, so you might want to be careful because the behavior tree, especially when it's not, I mean, the behavior tree is supposed to always be very reactive, very instantaneous. And if an action takes more than an instant of time to execute, then you should return a running. So by passing like a large amount of data, you might incur in a blocking behavior that blocks the whole deliberative process. Again, as Mark was saying, you can just pass a pointer and avoid this issue altogether.
Okay. Great. Makes sense.
But yes, I would absolutely use asynchronous behavior tree nodes to acquire the data and to also process the data, because I doubt that either of those steps are going to be instantaneous.
Okay. Makes sense. All right. Great. Thank you.
Yeah, so we could also feel free to. We could. I guess we can also later discuss some more points. But in terms of everyone presents themselves. Mark, I think I've seen you sometime in some ROS places before, but maybe could you also introduce yourself a little bit?
Sure thing. So yeah, I've been playing in ROS since, I don't know, like 2013, 2014. But up for the last 3 years, I've been working at Picnic Robotics. For the past 2 years of that, I've been integrating Davide's behavior tree library into MoveIt and basically autonomous based systems. And so recently left Picnic, and so free agent right now. But yeah, I just joined this group, just trying to get more grounded in how other people are using behavior trees. I've worked quite a bit with Davide, and I would like to start to contribute some more functionality to the library. So.
Okay. Yeah, I think something that is really missing there, and I see that you are now also a little bit maybe open for other solutions outside of Picnic. I think something that's missing is some kind of real standardized way to actually call the behavior tree from ROS, to use the library in ROS.
Correct. Yeah, and also how you register all of your plugins, and if you have some library of behaviors, you usually also have a library of subtrees, right? Submodules that use those behaviors to do a combined set of logic. And so how do you register all of those for, let's say, like a type of gripper, right? The gripper might have open and closed behaviors, but you might write some smart set of subtrees that can grasp things without crushing them, or do specific tasks with the tool. And so, yeah, that's one of the pieces I would like to start to contribute with.
Yeah,
so.
Sounds cool. Okay, maybe Matteo, could you say a few words about yourself?
Yeah, sure. Can you hear me? Okay. So I'm Matteo Morelli. I work at CA List in France, Commissariat à l'Énergie Atomique. So I work in the past. I've worked in model-driven engineering methods for developing robotics application using low-code approaches. And now I still work on this thematics, and I'm also started to deal with the implementation of some runtime frameworks to support the code, the execution of the code that we generate, because sometimes the code we generate can be too much low level, so we need to leverage some framework. So I did a presentation. I don't remember anymore. So the last presentation of this working group was on our recent working on software architecture for executing skill-based behaviors, based for the moment only on behavior trees, but we plan to add support for executing behaviors also formalized as final state machine. Actually, I found what Mark said interesting, because it's quite aligned with what we do. We developed a way to embed and reuse the good work done by Navigation 2 about the execution of behavior trees in a Navigation 2 agnostic way. So just extracting the neutral part of the library to have a nice framework to execute behavior trees in ROS, in any framework. So this is something that I think is available in Move-It Pro, and I discovered that Mark is involved in the development of this facility. Yeah, so we also have a way to reuse behaviors, as you said. We call that composite skills. So they are again behavior engines that can process another subtree independently. So, well, I think there is something that we could discuss together. As I said last time in the presentation, there is a video about that. So feel free to browse the minutes that Christian always do. It would be nice if, as an outcome of this working group, we could develop, make available a framework for everyone that everyone can use, an open source framework for the execution of behavior tree-based applications in ROS, because I think many people have these needs, many people are reinventing probably things, so maybe a commonly agreed ways to do that with a software package would be nice. Yeah. So if you are interested, we can discuss all this.
Okay, thank you.
That's it.
And Enrico?
Yes, hi. I'm Enrico. So for those who don't know me, because I work with Christian and Matteo in the Convince project. I'm a postdoc at the University of Genoa, and at the engineering and computer science department. And I work particularly on formal methods and modeling and verification of systems. In the Convince project, we are focusing on robotic systems, and which kind of are especially tricky because they involve kind of mixed models, in the sense that mix event-based models with time-based models. And so our goal is to be able to verify these in a approximate way, so not with 100% guarantee of correctness, because these systems are usually really huge and very difficult to verify by using standard methods. But we plan to use statistical model checking that consists in estimating a probability that the system will succeed, with confidence given by how well you manage to verify the system. So depending on time available for computation and the complexity of the system itself. And ROS and especially behavior trees come into this because the systems we are trying to verify, our use cases, use ROS and have behavior trees as the main kind of deliberative model, kind of task plan model for the deliberative layer. So first step is to model behavior trees, and then everything that comes after them.
Okay, thank you. So yeah, I mean this was originally the place where we started the working group, was convinced. And at some point we will have this output where we have a system where you could then verify or validate the workings of behavior trees in robotic systems. But I think, yeah, I also wanted to have the scope a little bit broader for this working group to generally talk about like other technologies that could be used in this field. It just happens to be sometimes it feels a bit like the behavior tree working group, but I guess that's how it is. So Enrico, you wanted to maybe give a brief update on our RAP. So the idea of the RAP is to standardize how behavior trees work, which mainly we actually need to verify them, because if we don't have a clear understanding of how they operate, we can't really do a lot of verification on them. Yeah.
Yes, that was the kind of original motivation for this effort. We want to verify behavior trees, but even the very definition of kind of behavior tree semantics is a bit fuzzy. And so we came up with a RAP that, I mean, I don't, it is a mix of prescriptive and descriptive. I would say that it's mostly descriptive in that it tries to kind of summarize the state of the art in a clear way. And there is only a tiny prescriptive component that is like if you want, you can implement behavior trees following this description and claim that it is conformant to this specification. Of course, there is no aim to impose it as a kind of to enforce people to use it. And so we started writing this document, this proposal. There was an initial feedback from Davide Faconti, who raised some good points. There were still a few points that were still a bit unclear, and I saw that Michele Colledanchise has commented in the repository, clarifying some points about terminology and the workings of behavior tree, at least from his point of view. So, I think that with this input, there is enough material, enough information to write a second draft of the RAP. Issue is right now I've been too busy with other things, so we don't have a new draft yet. But hopefully after ERF, there might be some time to work on it. And okay, so for I don't know if Mark and Alejandro were like in the meetings before. A big issue that we kind of had working with behavior trees is that there is a discrepancy between the in the notation, in the terminology between behavior tree.cpp and at least some of the literature. So yeah, we don't have the kind of ambition of correcting anyone. There are like different opinions of what the terminology should be, and this discrepancy will still be there. But we thought it would be useful to have somewhere to have a document written in which it says, look, this thing that on this here is called in this way, in here is called, in there is called in this other way.
Okay.
Because that's
Do you mean,
that,
for example, for the reactive sequence, reactive fallback, those type of things?
yes. So, for example, something that originally when I started working with behavior trees caused me to waste a lot of time is that in the behavior tree.cpp library, what is called sequence corresponds to what, for example, in Michele Poledanchisa's book, is called a reactive, no, it's called a sequence with memory. Whereas in the book, when they just write a sequence, they mean a reactive sequence.
Okay, I see.
So,
Yeah.
so if you assume that the terminology kind of aligns, you would think that the terminology aligns, but you would be making a mistake, and it can take some time to figure it out. So we thought it would be helpful to help future students of behavior tree by having this document written.
And I think that's true for most literature. When they mean the trees, when they mean sequence or react or fallback, they usually mean the reactive version because that's just the nature of behavior trees. And then I assume Davide took the decision to make them kind of the default version, those with memory, because that's probably more what a robotics engineer would think of, because you would kind of assume that the world has a given state and it keeps this state. But yeah, that's just not really how the literature views behavior trees in most cases, or at least not what the default of these nodes, of these control nodes are. So this was the biggest confusion that started this actually.
Yes, there is an underlying issue that these behavior trees arise in video game development where things work in a certain way and you don't have certain issues. When they started being using, they started being using in robotics, but then you have the issue that when a system is running, it doesn't just run discretely, like a step at a time, but it runs continuously. So if and system interacts with each other. So you generally only want one system to run at a time, and if two systems are running, you want to stop the other. I mean, before you run a system, you want to stop other systems that might be still running. So it was proposed an halt semantics, which is not as standard as the kind of reactive behavior, like reactive nodes and nodes with memory. And what it means is that you have to integrate the semantics of reactive nodes of the nodes, which is kind of commonly understood, with these halt semantics that is not so commonly agreed upon. So again, you have an issue of kind of defining how the halt semantics works precisely, because even small changes in the definition could have potential kind of consequences. And reactive nodes are kind of unsound with respect to the HUD semantics. There are deep issues, so that even if you try to halt if you with reactive nodes, you always have a possibility that two nodes are running at the same time and they interact with each other, which is a potential issue. Generally, what you do is, as soon as you see that that two systems are running at the same time, you try to stop one. But while you are stopping the system, that there is some overlapping in the running of the two systems. So this might be why Davide Faconti decided to have the standard nodes with memory as standard nodes, because reactive nodes are problematic in this respect. And at least my view with respect to the rep is to just mention the fact that this issue exists, and to leave it to the implementation or to the user to decide how to deal with it, because there is no universally accepted way to deal with it. And again, I don't think we are in the position of imposing on the community a solution. The most useful thing we can do is to document this issue and let people aware that it exists.
Is this something that you come across at Picnic as well,
And this is what I have.
Mark? I mean, I suppose if someone learns how to write behavior trees using the library, behavior tree.cpp, this person would already learn these things, how they are done in the library, and they would probably not really notice this too much. But if someone, for example, did behavior trees with another library before, or learned it very theoretically, then they could come across something, right? I mean, the idea is that users would write behavior trees in the Move It Pro, formerly known as Move It Studio, right?
Correct. Yeah. So as I learned this stuff, I mostly came up with behavior tree.cpp. So that's where I started to learn all of this stuff with. I would say the only kind of maybe recommendation I might have for this table is, I don't know if any of you guys have played with PyTrees, but do they follow the same standard? I'd say that's the second most popular version of this library. Other than that, as I looked through the rep, I mean, it looks pretty basic as far as here's the types of branching or decision-based blocks that you can make, and how they behave, whether you call them a sequence with memory or a sequence. Seems just like a minor detail. It is good, right? Depending on which way you've learned it, right? If you've gone classical approach, then yeah, it makes sense that you need to kind of know, hey, this translates slightly differently. So
have you worked with PyTrees?
I have. I looked into it quite a bit, but no, I have not played with it. I mean, I've gone through their GitHub tutorials and stuff like that. It looks very similar. I don't know, as Picnic was researching this kind of stuff and deploying it to customers, we had a strong pull in lots of people wanted to do this in Python.
Okay.
And so we for the way that they kind of held that gap is that we made a class that would allow you to easily set up a action client or service client with ROS, and then you could call your Python-based server to do whatever logic you wanted. So that made it so that people could write anything they wanted. And the nice thing about that also was, like, as we made like ML-based behaviors, it decoupled the fact that you had to be within the same working space, right? You could be in separate Docker containers because ROS will talk across different machines and everything else. And so it made it so that you didn't have to exactly align all of your dependencies.
Yeah, and this was also something I had. You quickly get the impression that it's very much tailored towards like C++ development lifecycle. So, if you're someone that would be happy to program the robot in C++, the logic, there are people that program logic in C++. Yeah, then you're probably happy with DelibWG.cpp. But if you want something that's a little bit more flexible, and yeah, there's actually something else that I wanted to point out. I put a link in the chat as well. That's this. There's also a library from the FZI. That's also German Applied Research Institute, and they actually made a behavior tree runtime that's, as far as I know, it has nothing to do with PyTrees, but it's made in Python as well, and it's very, very reactive. So you can basically at runtime have a nice GUI, and you can at runtime change the tree and dynamically assign actions to ROS actions and to ROS services and so on. And that's very. I only looked at it while they showed it to me, and I've not yet played with it myself, but I think it's super promising. But yeah, also this regard, I think it would be cool if you could go ahead and design your prototyping behavior tree in ROS BT.py in ROS BT.py, and then could transform it and use it in bt.cpp, right? So this would be also something that this rep could enable if we have like the clear understanding how to translate this.
Did they have any type of suggestions or design patterns that made their systems more reactive? Like, that was one of the problems I've really had with using behavior trees, is like making something highly reactive and being able to fall back to the right step was an extremely difficult task within behavior trees. As I've been studying this, I started learning about Isaacsen's Cortex library. They have a decider network. It's not an AI network, it's just a tree of decisions, and how you build the most important decision or fall back to the correct stage as you're completing a task.
Basically a decision tree.
Very flexible, very cool. It seems like, as I've been doing it, you need a little mix of both, right? I think the behavior tree library makes sense as you're like deciding what you need to do, and then this makes a lot more sense as far as like actually completing certain tasks where there could be lots of different failure modes.
Yeah, I guess what I meant with reactive is kind of also the runtime is very reactive, which simply means you don't have to recompile your C++ whenever you change something in the tree. So I guess the reactiveness you're referring to is like, from the tree itself, which of course is also interesting.
Right.
Yeah.
So if you look through this Omniverse example here, like if you're holding an object and you're moving it to the scene and you drop it, the robot needs to go and pick it back up wherever it fell. And so like writing that with a behavior tree, it's very difficult.
Yeah, actually, like I'm not sure, but for me this decider network looks very much like a decision tree, which is like a machine learning technique, right? So where you just decide which parameter to evaluate on which leaf. And there are actually people that learn behavior trees from demonstration using a kind of if I could only find a paper. They basically use a transformation from decision trees to behavior trees, which is pretty straightforward. You can just make a condition like a pair of a. Here it is. Yeah, I got it. So maybe this could bridge the gap between your the Isaac thing and the behavior trees.
Yeah, it's a nice. If you look through the Omniverse Cortex stuff, they do a lot of contrasting with state machines and how you can mix state machines with decider networks. And
Yeah.
so, yeah, very cool
Okay.
stuff.
I've never worked with this. What is the idea of Cortex?
Cortex is just the name of the library. So it's just a Python-based library of how you register a bunch of decisions as far as like what needs to happen and like how it can decide what the most, or how it figures out what the most important decision to make is, right? So as it's as it's moving the block and it drops it, oh, well, I got to cancel this certain task and I got to go back to pick up the object, or I'm making a stack of objects in a certain order and maybe it falls over. Okay, I got to start over and start to rebuild the stack again.
Okay. So it's basically.
So it's just a Python-based library of like making these decision points and then triggering it in a very fast fashion as far as like percolating the most important decision to the top.
Okay. Yeah, so it feels almost like a deliberation system, at least for some ways of understanding the deliberation topic.
Yeah. So that's one of the things I'd like to try to even play with also is like how do you make a slightly more reactive system, right? The behavior tree is gonna be like, oh, you need to go pick up an object. Let's activate this network that can figure out and be fault tolerant to robot not getting it quite right all the time. And then also switching to different tasks like, oh, now I need to go open a drawer. Well, those have different faults and fallbacks than moving objects does.
Yeah. So now, how would you compare this, like the workflow with that in comparison to behavior trees?
Like I said, like as in behavior trees, to like make like a fault tolerant system. Like, so one of the problems I had was like an example of like, let's say that you're doing like a bin picking application, right? You say pick 3 items out of the bin, but there's many more than that in there. Some of those objects might not be pickable because your gripper would be in collision with the tote. And so to make a behavior tree node that loops through all of the objects in the bin until it actually picks 3, but some of their plans might fail, to draw the entire behavior tree out, like it turns into this very unintuitive structure that like handing it to anybody else, they'd be like, what did you make here? Like, I don't even understand what this does. And so, yeah, I'm hoping that like using something like these decider networks where you can create these discrete transitions as far as like, oh, okay, if you drop the object, you need to go pick it back up or build this other thing back up. And so, yeah, I see it as far as like, I see behavior trees being used more as like a very high level state machine, right? That might have certain levels of fallback. And then you use these decider based networks to distill certain skills or tasks.
Ah, okay. Yeah. Yeah, interesting. Okay, cool. Has someone else a topic they would like to bring up? Ah, Stefano is here as well. Hi. Yes.
Hello, sorry for the delay.
No problem.
Oh,
So Stefano is also from our. I say Stefano. I of course mean Stefano. Excuse me. He's also from our Convince project. From IIT. Yeah. But if no one else has a point to discuss, then I'm also happy to close the meeting right now. I hope this bit more open style was also good, because I think this way we can have more of a conversation rather than just listening to a person that teaching something, because this you can also do with writing, and yeah, I suppose we will have a mix of that. And I will also look into our rep again if I find the time. I guess I will find the time, because you guys a lot of you guys will be in Rimini. Yeah, exactly. Good. Then have a nice week, everyone.
You too.
Nice to meet everybody.
Thank you. Nice to meet you.
Bye.
Thank you,
Bye.
Kristen. You too.
See you.
Nice to meet you, everyone.